Now let's look at another example problem. This is also a problem involving two strings called the wildcard matching. So we are given two strings, but one of them is a string, the other is a pattern. So the pattern can include letters and also this question mark, which will match one letter, or this is star, which can match 0 or more letters. So this is a notation from a regular expression, but for this particular question, you don't have to know how regular expression works. Just need to know that question mark will match a single character, and star can match any sequence of character, including empty sequence. And the matching should cover the entire input string and not partial. So for example, this string will match with this pattern, and this will not. So encourage you to look at them and think through why it matches, why it doesn't. So let's look at these first input. So we have an A here, we have an A here. So the pattern, these patterns A can match only in this A. So, and if we match that, then this star, first star will match empty string, which is fine. And then the B will need to match the last B here. So then the question mark will match whatever letter before B, so we'll match E. So then this star will match things that are between A and E. So basically this is a DC part, so that works. This star match this two-letter sequence. And if we look at this, A matches A, B matches B, the question mark must match with this C. But then the one before it doesn't match. So the C need to match with D, but it doesn't. So that's why the output for this is false. So encourage you to pause the video, try to solve the problem on LeetCode. Okay. So again, we are using this two-dimensional table. So we have each row is for the so the horizontal we have the string, and the vertical we have the pattern. So the initialization value is actually a little bit require a little bit of thinking. So empty strings means empty pattern can match with empty string. So nothing can match with nothing. But empty pattern cannot match with a non-empty string. So then we have the first, this one being true, but everything else on the first row being false. So now the question is, how do we initialize? So also actually, how do we initialize the first column? So when we see a star, then the star will be able to match with, the star can match anything. So we basically look at what's before this star. So the before this star, it is true. So therefore, this will also be true. But if it's a letter or a question mark, it needs to match something. So then when we are matching that with empty string, it has to be false. And when we are seeing a star, this star itself can match with anything. So we need to look at the prefix. What is the prefix? So because the previous one is false, then this has to be also false. So in fact, anytime we have a false, things that are below it can only be false in the first column. Now, how do we fill a cell in here rather than the initialization? So again, we need to do case. So there are three top level cases. The thing we're looking at in the pattern is a letter, is a question mark or a star. So think about what is the condition to fill how do we fill the table when it's a letter? So if we see a letter, then this letter need to match in the pattern. This letter in the pattern need to match the letter in the string. But after it matches, then the prefix need to match. So then there are basically two cases. First, if it matches, so in this case, this A matches this, then we need to look at the prefix. So go diagonal. Because that is true, then this should also be true. So here, similarly, this A and A matches, we can go diagonal. So do we have a case where letter matches, but then the diagonal is wrong? We actually don't have it in here. Yeah, we actually don't have it in here. But for the last B, because it matches this, we will go diagonal. And because this is true, then this should be true. If the letter does not equal with the current letter in the string, we'll feel false. So that's how we fill a row corresponding with the letter in the pattern. For a question mark, then it's easy because well, it's similar to letter. Just we don't care what the actual letter is in the string. It can always match. We always go diagonal. So this question mark actually can match with A, but because we need to go diagonal, then to check what about the prefix, and turns out the prefix cannot match. So this is false. So then this needs to be false. The question mark matches with it can match with D, so we go diagonal. So this question mark means we are basically copying diagonal down here. So star is the hardest thing to deal with. So when we have a star, it can matches anything, any length. So for example, if we have this star, the prefix of the pattern can match anything up to now. So we go up. If we see a true, then that means the prefix can up to here. Then this star can match with empty. So that is okay for this thing to be true. For here, when we go up, when we see the prefix, this prefix cannot match up to the D, up to AD. So then, but then star can handle that. So when we go up, we just need to, if we see a false, we need to keep going left. The moment we see a true, this one can be a true, because all the things that can be after this match can be matched with the star. So when we see a star, we will go up, and then we will keep going left. The moment we see a true, we know this is true. But if everything to the left is false, then it has to be a false. So I guess yeah, we don't have a very good example in here. So except only here, when we go up, we see a false. So there's nothing. Yeah, when we go left, there's nothing on the left. Yeah. So that's how we deal with the star. So another thing is think about what is computational complexity if we do this. If we go up to match a star, if we see false, we go left. If we see false, we keep going left. So that to fill this one cell, it might appear that we will need the linear time. So then this will make the whole complexity cubic instead of quadratic, but that's actually not necessary. So this slide essentially gives the formula, the code for the ones for the thing we just discussed. If it's a letter, then we check whether it matches. If it matches, then it's go to diagonal. Otherwise, it's false. So if it's a question mark, we go diagonal. If it's a star, we need to logically OR everything on the row above up to the current column. So naive implementation have a cubic time, but while we are scanning this row from left to right, we can keep track of this OR result. So each time we just need to OR with a new thing. So then that's still we can feel this cell can still be done in constant time. So OR, this can still be done in quadratic complexity. So these are the problems that I find. DP problem involving two strings. There are probably some new problems now because I guess here I only went to 1100. I think I collected the list maybe a year and a half ago. So we talk about these two example problems, and there are several others that you can try. So so I think so I like to say that you should do any DP problem you see, because if you're already fluent with it, it generally takes a very little time, so just a couple of minutes. So if you're not, so you're not wasting too much time if you already know it. On the other hand, if you can solve it in a few minutes, then that means you need the practice. So encourage you to solve all of these DP problems.